In this problem, we're given a set of data, and we are to determine the value of y when x is 0. The key information in this problem is that we are to assume that the data in the table are linear. The fact that they said the data are linear means that if you were to pick any 2 points and calculate the slope, you'd always get the same result. In a minute, I will show you the slope formula and show how you would do this problem if it were more complicated. However, in this problem, because they chose to give you data such that the x values were increasing by 1, I can tell the intent of the problem was for you to know that slope is how much change in y is there every time x increases by 1. So if you look at this number's 24 and this number's 15, if I were to take 15 and subtract 24, that would tell me how much change in y there is. 15 subtract 24 is negative 9. What that means is to go from 24 to 15, you would have to subtract 9. This pattern continues because the data is linear. If x changed from 2 to 3, meaning if I increase x by 1 again, then y should go down 9 again, or you can think of it as you're adding negative 9 or subtracting 9. 15 subtract 9 is indeed 6. So now, to find out what happens at x equals 0, I need to work backwards in the chart. If going down the chart is subtract 9, how could you get from numbers at the bottom of the chart and move upward? You'd have to do the inverse of subtracting 9, and the inverse of subtracting 9 is to add 9. So to get from 6 back to 15, you would have to add 9, and to get from 15 to 24, you'd have to add 9 again. So that means to get the cell right before the 24, I would take 24 and add 9. And 24 plus 9 is 33. So when x is 0, we were to find the value of y, and we did just that. When x is 0, y is 33. You can check and see that if you took 33 and subtracted 9, you'd get 24, and then the pattern continues. Every time x goes up by 1, y goes down 9. Now that we're at the end of the video, I'd like to show you what would happen had they not been so nice. Suppose they would have given you all of the data they gave you before, keep the question the same, but suppose they removed just these 2 data points. Now my x's aren't going up by 1. In fact, to get from this x value to this x value, you'd have to go up by 2. And to get from 24 to 6, you'd have to subtract 18. It turns out that the slope formula that you're probably aware of actually gives you the same information. So, for example, if I took y sub 2, my second y value of 6, and I subtracted y1, my first y value of 24, and then divide by my second x value of 3, and then subtract off my first x value, x of 1, which is 1, I would get that 6 subtract 24 is negative 18. Just like I found here, to get from 24 to 6, you have to subtract 18. Then when I subtracted x values, 3 minus 1, to get 2, that just tells me that my x values went up 2. So this tells me if I change x by adding 2, then y will change by subtracting 18. If you wanted to simplify, negative 18 divided by 2 is negative 9 divided by 1. So what this says, if you let me use the triangle to represent the words change in, this means, since this is my slope, and slope is change in y over change in x, that if I change x by 2, which we did, y will change by negative 18, and negative change means go down, so it went down 18. Well, after simplification, what this is telling me that if the change in x is 1, then the change in y will be minus 9. This is what I would need to go backwards in the chart, because I'm trying to figure out the value of y when x is 0, and I have the value of y when x is 1. So I want to know how much change occurred in the y if I were only to increase x by 1, not 2. And this tells me if I increase x by 1, the y value should go down 9. So I'm to find the number that if I subtracted 9, you would get 24. And you'd still be able to ascertain that the answer is 33. 33 is the number that if you subtracted 9, you would get to 24.